this case, we are going to test a fire pump motor, first with the all test and then with the Baker AWA 4 6 kV unit. For the all test equipment, I'm going to go ahead and do the auto mode, short the leads together. Connect the winding. Run the test. Phase 1. Connect winding 2. Run the test. Connect to winding 3. Run the test. Okay. Press OK. Do an insulation to ground test. Yes, we will. Change my lead position. Press OK. Press and hold the lead. At greater than 100 megohms, press OK. You can save our data. A, B, C. Phase. Save it. Yes. What we're looking at here is we have slightly unbalanced resistance. The phase angle is off by more than 1 degree, meaning we have some type of short. Measured balanced here and balanced here, so looks like we have a slight short. What we'll do is we'll change the shaft position, run the test one more time. Shaft position is changed 90 degrees. We rerun the test. Check again. Press OK. The next lead. Press OK. And this in the same order. Press OK. Press OK. Skip the insulation test, we'd already done it. You'll note that there's been a slight change. Resistance is balanced. I've got 6 and 5 ohms of impedance. My phase angle has changed position. This means that my phase angle unbalance is due to rotor bars. So I have casting voids or bad rotor. Press down here and everything else is balances has changed as well. Again, that indicates the rotor. You change the shaft position and you change and you keep everything else the same and it changes by phase, then the problem is in the rotor. In this case, we're testing the AWA 4 6 kV unit on this machine, same one we did the all test on, which is a 50 horsepower machine. In this case, set up for 200 volts. So we're going to set up as a 230 volt in the machine. So what we need to do is add a new motor. We do this. We've already got the database set up for our incoming area. We're going to call this by the job number. The model number here is a T672. It is a US electric. Serial number Voltage rating is 200 volts. It's a 50 horsepower machine. Open drift proof. We are connected for 200 volts. Say 230 in this case. Insulation class F. 1.15. Amp rating is 131 amps. The RPM is 1780. 60 hertz. Operating amp, of course, is 131. Frame is a 326T. The code is a G. Design B, 40 degrees B. Okay. I'm not going to bother with the efficiency. Now we're going to save this. And it's also connected delta. It's a little touchy. Delta. Save this. I'm going to do this as a 230 volt connection that we had set up. The setup can be very interesting, but for this particular presentation, for this particular one, we're going to do this. Okay, so we're now set up to do the 230 volt testing. So we got all this stuff entered. We go to tests. Have it set up already for resistance. Megger test the dielectric absorption only. A high pod 700 volts. The surge to 700 volts only. We now connect the leads and ground. Which are all set. And we run the auto test. Press both and let it run. We need to enter in the temperature. Today it's a little cooler today, so about 75 degrees in here. That would be Fahrenheit. Accept it. Then we allow it to operate. Whoops. Well, let's try that again. Going to abort out of that. Stop this test. I'm going to run the auto test again. Okay. Degrees C, so we'll just call this 19 degrees C. Accept it. You notice that it is running its measurements. The Kelvin bridge first. 361, 361. 0.0361. Just going to say that was acceptable. Passed. It is now running the Megger and the dielectric absorption for 1 minute. As soon as it comes up to voltage, which it ramps up, it will then begin timing down. Reading's not too bad so far, but let's see what it has to say, because it will correct for temperature for us. Okay, and now it's doing its dielectric absorption, which it does another 2 minutes of test. It actually takes a ratio of the 3 minute to 1 minute versus your 1 minute, 30 seconds to 1 minute, which is the actual defined. I guess my real question is, am I going to fit in the 10-minute YouTube requirement? A polarization index test would be a complete 10-minute test. In that case, I decided to skip that. Now here we are, we're doing a straight high pot. We're not doing the step voltage test, which will take a little longer. And we're going to see what the test results are, what kind of leakage we get after 1 minute. Good news is that this motor apparently had been submerged in recent storms during June of 2010. So it passed that, and it's now going to the surge test. Now that's auto ranging right now. I'm going to try to keep this part intact for the video. These were also only surging to 700 volts. Completed all the tests. While we continue to do our evaluation of this technology, one of the challenges for a portable piece of equipment like this is that this is about 40 pounds and you need to have an outlet. So what we're going to do, we're going to bring over a couple of motors to here because it's difficult to bring this there, especially when plugs are not all over the place, unless we have a long extension cord. And we're going to continue to do some comparisons of the two pieces of equipment in series videos. Baker offers some very nice features that we will take advantage of. And we'll discuss some of those. And I'm going to try to make it so that you can see the screen and we can watch a full test in action. I'm going to shortcut some of the data entry stuff because, to be perfectly honest, trying to get this stuff on YouTube and it takes 15-20 minutes to do a single test or longer is not feasible. So I'm going to do some of the shorter versions of the testing on the equipment and compare it to the All-Test 4. The first motor we're going to test is a simple Lafert motor that we have also previously tested. First set of tests will be the All-Test 4. The All-Test 4 does a series of tests, takes about 30 seconds to perform. What we're going to do is we're going to use the auto mode, in which we compare the test leads for a 2-wire Kelvin bridge. This motor is set up for 460 volts. It is a used motor, it's been used in the field. We'll press our first winding. It runs through its tests. Okay, we press OK, and now we're going to go on to the second phase. This, in both cases, both the Baker and the All-Test unit are supposed to be able to operate from a motor control or disconnect. Okay, and then the last phase. And press it, and we let it run. Okay. Yes, we're going to do the insulation to ground test. Move our terminals. Connect to a ground. Press OK, and then press and hold the insul key. 500 volts. And our reading is greater than 100 megohms. Press OK. Now, before you do anything, you want to save. We'll just call this A, B, C. Phase. Save the name. Got high, low, high, 69 straight across, balanced, and everything's balanced, so we know the winding is good. Now let's compare that to the Baker. Okay, on the Baker we're going to go straight. Some straight tests. We're going to include the resistance reading, which we have to enter manual temperature. We're going to do a mega reading, polarization index. I'm skipping the ramp because that takes a little bit, and we'll go straight to the surge. The high pot and the surge test will both be at 2,000 volts. When we run the auto test, Yes, we're going to use the change parameters. And the first thing it does is wants to verify the temperature in degrees Fahrenheit. It is about 80 degrees today, so we'll accept that. The nice thing is these tests are now going to happen automatically, and it's now running my straight 4-wire Kelvin resistance test. So far, all balanced as compared to the original, and it's now doing the third phase. Okay, with that test complete, it will now run my Megger test for 1 minute. As soon as it brings the voltage up to the required temperature of value of 500 volts. Now we're already in the 18 gigohm range, or sorry, 11 gigohm range. Should be showing up on the screen a little bit better than on our first set of tests on the fire pump, which a lot of these we just cut down because the time ran about 5 minutes over the 10-minute minimum. And this is our dielectric absorption, which is an additional 2 minutes. See the Megger reading is pretty much balanced out. Okay, the next test is going to be the high potential test. Once it gets up to a value of 2,000 volts, it will then run it for roughly 30 seconds, and it'll tell us what our leakage looks like. This motor, of course, has the rotor in place, so the test when this one is complete will be my surge comparison test with a rotor. Discharge the winding, and now comes our surge test at 2000 volts. It's set to auto range. This will be phase 1 waveform, okay, followed by phase 2. This again is happening automatically. That's nice and sync. Followed by phase 3. Okay, that thereby completes the tests, and as you can see, passed all of the tests, ending up with the same good results as the all test 4, which makes for a pretty good comparison. We're now going to test a submersible pump. And in this video we're going to test this submersible pump. First we use the all test 4 again. Short our leads out, auto mode, compare. Okay, connect winding 1. And press OK, and we allow it to run the tests. Okay, that's phase 1. We're going to connect phase 2 and run our tests again. And last, move one more lead. We run the final phase. Okay. Then we do our insulation test. Press OK, press and hold. And we have more than 100 megohms. Press OK, we save, and we are done. We take a look at our readings. Everything appears to be relatively balanced. Low, high, medium on my impedance. 72, 71, 72, that's good. Low, high, medium on my inductance. 40, 39, 40, that's good as well. So, done with the test. Winding looks good. Okay, in this case what I've done again, I've taken the about 3 minutes to enter in the nameplate data. And I'm preparing now to run the tests also on that same submersible pump. I can press the screen as well in order to run things. And we start out, and we know it's 80 degrees Fahrenheit. We accept that reading, and we allow it to start running its tests. As we saw, the all test is tested as good. We shall see if we'll get the same results with the AWA. Did the same thing as I did on a previous test where I've changed it from the step voltage high pot to a straight 30-second high pot so that I can meet the requirements for YouTube without having to take out any time on demonstrating the tests. Perfectly balanced. So now we're going to go to our Megger test, 500 volts. Leakage current's a little higher than the last motor that we tested, about 2.6 microamps. But let's see what happens with our megohms, which are staying at about 192 megohms. The question will be what happens with the dielectric absorption test. So our insulation resistance continues to climb just a bit. Now we're going to a DA test, dielectric absorption. Reading remains relatively flat, so I have a feeling this one may be borderline or fail the dielectric absorption. Okay, now we're going to do our high potential test, 2,000 volts, and the leakage is definitely coming up. So the question is, will it actually perform the test? Now it's holding at 12 microamps, and the Megger test is sitting at 167 megohms at 2,000 volts, so we'll see what happens. The big test will be again the surge test. Discharged. And last but not least, our surge test. 2,000 volts. It's a relatively new winding. Lead 1. You notice the curve does not have a familiar ringing effect. This is in effect due to the rotor that's in the stator. It has some influence on the what's called tank circuit between the surge test and the inductance of the winding. Okay, you've got a separation between the two. The question is that separation deemed acceptable by the test equipment? And more than likely is due to the rotor. It's significantly different. And the AWA has deemed this as passed.